Hello everyone, welcome to my YouTube channel. My name is Dr. Nandita Raha and I did my PhD in particle physics from the University of Kentucky in United States. I came back to India to join Delhi Public School as a physics teacher, and my goal is to build your foundation in physics so strong that you can nail all kinds of exams. I won't restrict our horizon only to 𝗖𝗔 or CBSE board exams, but train you for JEE, NEET and all other entrance exams, medical or engineering. So subscribe my channel to get the best out of it. I will follow up with tons of numerical problems to reinforce your basics. As you know, physics is the hardest part, and if you master it, you can crack any exam. I've started with class 12th syllabus, but will eventually cover up 11th also. Without further ado, let's get started with electrostatics. So what is electrostatics? Electrostatics is a branch of physics which deals with the study of forces, fields, and potentials arising from static charges. In this topic, we will be learning about electric charges and fields, Gauss theorem, electric potential and potential energy, and finally capacitors and dielectrics. For the first unit, in this video, I'll be covering electric charges which are both positive and negative, and electron theory of electrification, basic property of charge, and which is additivity of charges, quantization of charge, and conservation of charge. Okay, and this will be followed with tons of numerical problems on this topic in the next video. This will include questions from previous years CBSE, ISC, JEE, and NEET. Electric charges, positive and negative charges. Let's begin with a simple activity. Rub a plastic comb or rod and roll it over bits of foil papers. What do you see? Yes, you see that the foil is attracted towards the rod. Why is this happening? It's happening because of electrification. So the rod acquires a certain charge, and due to rubbing, which could be positive or negative, which we will be seeing in the next session. And the charge it acquires could either be a positive charge or a negative charge, whereas the bits of paper are still neutral, and so they are attracted towards the rod. So what we notice is that either there is a repulsion of charge or there's an attraction of charge. So the like charges will always repel each other. Like, let's see in this example below. Two positive charges are always repelling each other, and similarly two negative charges are also always repelling each other. And we also notice that unlike charges will be attracting each other. Let's see in this example below that the positive charge in red and the negative in blue are attracting, as you can see clearly. So this is because this is a fundamental force in nature, and that is how it behaves. Like if you have similar charges, they'll be attracting, and if you have if you have similar charges, they'll be repelling, and if you have opposite charges, they'll be attracting. That opposites attract. And this can be proved later on mathematically using Coulomb's law, which we'll be seeing in a couple of sessions from now. So let us see what is electron theory of electrification. For this, we must understand what is charging by friction. In the previous example, let's get back to it. As you remember, we were rubbing a plastic comb, say on your hair, and what happens is in the process of rubbing, the comb acquires some electrons. It gains electrons, and when it gains electrons, it becomes negatively charged. Similarly, if you take a silk cloth and rub it with the glass rod, the glass rod becomes positively charged. So the plastic rod becomes negatively charged, and the glass rod becomes positively charged. As you can see in this figure below, that I'm rubbing a glass rod, it becomes positively charged, and when I rub a plastic rod with silk, it becomes negatively charged. Now when you get the two glass rods close to each other, as in this case, first case, we find that they will be repelling each other, whereas if you get the plastic and the glass close to each other, they'll be attracting each other, as you can see from the further end. So what happens again is called frictional electricity. We know that the atom is made up of electrons, outer electrons, as you can see in the figure, and when you rub a certain object, two bodies together, electrons are either gained or lost, as we saw in the previous example, And if electrons are gained, then it becomes negatively charged, and if electrons are lost, it becomes positively charged. Okay. So all charges in this universe are because of electrons. This is what is the electron theory of electrification. So electrification is either due to lack of electrons or excess of electrons, and electrons only. Okay. So if you have lack, and electrons are considered to be negatively charged, so if there's excess of electrons, the body is negatively charged, and if there's a lack of electrons, the body is positively charged. Lack of electrons means positively charged. Next, let us see what are the basic properties of charge. Here we consider a point charge. What is a point charge? It means that the size of the body is negligible compared to the distance between them. So such a charge is called a point charge. So let us take up the property of additivity of charges. Here we consider several point charges, Q1, Q2, Q3 up to Qn, and we bring them together. Then what happens is the body acquires a net charge Q, which is the sum of all these individual charges. But make sure to consider the sign when you're making this summation. For positive charges, it will be plus, but for negative charges, it will be subtracted. And it's important to remember that charge is a scalar invariant. Though it has a positive and a negative sign, but it is scalar and it is invariant. That is, there is no effect of direction in adding up these charges. They can be located anywhere in space. So after this, we learn what is conservation of charge. Conservation of charge means that the total charge in an isolated system is conserved. You cannot create nor can you destroy charges. So come back to the example where we take a silk cloth and rub it against a glass rod. So what happens is the glass rod will acquire positive charge. Why? Because it will lose some electrons, and what the exact number of electrons which the glass rod loses will be gained by the silk. So that gain will give it an exact amount of negative charge. So if 10 electrons are lost by the glass rod, then 10 electrons will be gained by the silk thread. Okay, but in case we are rubbing a plastic rod with the silk, just the reverse happens. This is just because of just the nature of these materials, these insulating materials. Another thing to note is that if you have insulators, they store the charge in them and they don't let it pass through, whereas if you have conductors, the passage of charges is much easier. Okay, but this is all about conservation, that the net charge will remain same in both cases, or in every case, every isolated system. Finally, we learn about quantization of charge. As I already said, that charge is because of electrons, so that's why the net charge of a body will always be given by n times E, where E is the electronic charge and n is an integer. The electronic charge is 1.6 times 10 to the minus 19 coulombs. So what is a coulomb now? So coulomb is the SI unit of charge, and it is the charge flowing through a wire in 1 second if the current is 1 ampere. Okay, so the fun fact is current is nothing but the rate of change of charge flowing through an object. Okay, so current is the rate of flow of charge. We will be learning about current electricity in a much later chapter, but right now just to make a note that current is because of flowing charges. Okay, so next we will cover up lots and lots of numericals in the next video, so stay tuned, and thank you for listening and hope you have a good day.